Alright, so here's a brief tutorial over, mainly for myself, how I created these horse track plots, horse race, horse track. That's what I call them because it reminds me of the carnival game in which you squirt the water gun into the hole and your horses race across the track. Anyway, we have some libraries here that we need to install. A couple of functions that we'll use later, pretty self-explanatory. colMax, colMin, and colmean. Bring in the data, pretty straightforward data. I'm going to be focusing on this particular column, and it is numerical values, but I need to make it into a factor, so it's not seen by ggplot as a numerical number or continuous data. So I want to split my data into 3 parts, each with the different days that I took the measurements, day 6, day 9, and day 12, just using the subset function. Then I want to look at the numbers, the columns that are numbers, numerical data, and not look at any of the metadata or data that is describing the data, like the day, the entry number, the country of origin, that sort of thing. So when pulling through the loop, I need to create this variable column number. Create an empty data frame and start filling that data frame with the entry that I have, the entry numbers, the day. For instance, this is day 6. The variable that I'm interested in, this is the cluster, the t-sneak cluster, k2, k-means is equal to 2. Fill your data frame with that. And then with each column, I want to calculate the min, the max, and the spread across that data frame. So from column 27 to the end of that data frame. And I want to generate numbers for each column, which I'll use later in the loop. And there they are. Sorry, that's not the numbers, that's just the numbers. That's the data frame without any metadata involved, just the numerical values. And I want to run through this loop in which I will go through column 27 until the end of the data frame and look at one column at a time. Look at each column is a different trait, a root trait that I've been looked at. Calculate the max and the min of each column, and as well as the spread of each individual column. And then for each value within each column, I want to normalize that number using the max and the min. So actually not using the max, just using a min. So taking that number and subtracting from it the smallest number in that column and dividing it over the spread, and that will normalize the number between 0 and 1. The maximum number in the column will thus become 1, and the minimum number in the column will thus become 0, and the rest of the numbers will then become a distribution between 1 and 0, and therefore be normalized. And no matter the scale between the different measurements, everything will be between a 1 and a 0. And I'll iterate over this through this for loop for every column, every trait. So I'm basically going to run this through, and it'll run it through, and it produce this data frame, data 6 normalized output, which is this one here. And we have the entry number, so which genotype, what day it is. They'll all be day 6 because that's the loop that I'm on. And then the cluster, whether it be cluster 1 or cluster 2, and all these values will be anywhere between a 0 and a 1. The 1 will be the highest value, and the 0 will be the lowest value. So they're within each individual column for all these traits across the board. So I want to do the same thing with the day 9 data, exactly the same thing with the day 12 data, and just run through it like that. I have that just to remove if I have been running this more than once. Anyway, then I want to melt the data to make it easier for ggplot to be able to plot it. So I'll have a melted data set for each of those 3 days, day 6, day 9, and day 12, and it'll melt it around the value based on tsne. So if we look at day 6 melt, we have the tsne value and then the variable and the value that it gives. So we went from having a wide data frame to a very skinny, narrow, long data frame. Where am I? And we're back. So we went through the melting, and now that we've completed the data as a whole and looked at the distribution from each individual trait, we have to look at the distribution of the clusters. So we group genotypes within the cluster, whether it be cluster 1 or cluster 2, and we find the mean of those clusters and see how the mean of those clusters differ at every individual trait through the data set. So first I'm going to make a list of these data frames, the day 6, day 9, and day 12 data frames, so we can iterate through the list. Grab the column names of those, create a new data frame for the output, create a list of days, so day 6, day 9, and day 12, which we'll use within the loop, and do the same thing but for the different TC lists. And really this should only be 2. I had it set on 9 because I was looking at 9 clusters previously, so we'll change that to just being 2. So then we can actually go through these 2 clusters. There should only be 2 as well. So there's a double loop here, a loop inside of a loop. This inside loop is going through each individual cluster, and this outside loop is paging through each of these data frames, so the day 6, day 9, and day 12. So it'll start with the day 6, and then it'll go through within the day 6. It'll look at the filter into either one of 2 clusters, and it'll take the mean of that cluster and then create a new data frame for the mean of that cluster for every trait. And then it'll iterate through the next day, which is day 9, and create another data frame for day 9. So we'll have 3 data frames, essentially having the mean of both clusters for every trait at each of the 3 days. I'll fly through that. It's done. So at the end, we should have day data output. And for each day, we have 2 clusters, 1 in cluster 2. So day 6, day 9, and day 12, and we have the means for each. And you can say the means on this first row are lower than the means on the second row by and large. And the same as for this one, and well, for this one it's upside down. Interesting. Okay. Well, that was seed weight. Seed weight shouldn't change at all. Okay, so we're done through that. Set them both as factors again, just to be sure. We can look up. Sure enough, they're both set as factors because even though they're numerical values, it says a day is not a continuous number, and the grouping, the cluster is not continuous. So we melt everything, And then we break it up into clusters again and remove the day from the cluster. However, we do have it in the name. And then we can write them to a CSV file, so we have those means for each cluster, as well as we can graph them. I'm going to do that here. I usually set my graphing up to output to a TIFF file where I want it. But for the means of this tutorial, I'll just run this ggplot. So I have two sets of graphing functions. I first have just the regular ggplot to create the scatter plot. And then within that ggplot, I have this geom point, which is creating the scatter plot itself, and then a geom line, which creates a line, the horse track race line, which looks at just the clustering data. So the first part of the tutorial was for this data, so all the data, and the second part was just for the clustering data. And then I have my theme and some other variables set in here, which are optional. So I'm going to run this plot, and it should run and print over in this section. And there we go. It's a little bit large. I'm going to see if I can move this size down to 1 for this. Oh, it did. Okay, when I spread it across. So you can see that we had two clusters. One was by and large above the other. So these are the means of the two clusters, hence why I get the name the horse race. And then the distribution of each trait that I'm interested in is down here. And you can see them printed down here. And obviously these are all these variables are adjustable within the ggplot2 code. There you go. Good luck and take her easy.